Okay, let's start. So your revision has been done for weeks 1 to 4, right?
Yes, ma'am.
Yes, ma'am.
Okay, so today we will do 5 to 8, and then Saturday, or I think Saturday is the next session, or Friday. So then you will do 9 to 12. Okay. So I'll share the screen. Right. If you have any question from the theoretical part, then you can ask. Okay. Any doubt if you have from weeks 5 to 8.
Ma'am, could you just go through the slides once, like from week to five, 5 to 8, just or example slides is there, right? For list and dictionaries, could you just go through them?
See, what I thought is that I will just give you a brief summary of what list and dictionaries are, okay? And then we'll solve these questions. After that, if you have any doubt, we'll take that.
Okay, ma'am, no problem.
All right. So first, let's go over some basic concepts. So
काले गोरे कभी
please mute yourself, others. Okay. So first, tell me, anyone, any one difference between list and dictionary?
I mean, list random access is not possible, while in dictionary it's possible.
Right. So no random access in list. And here we can do random access. Now, how is random access possible in dictionary?
Ma'am, we can call that particular key to search the value.
Right. So random access via keys. So dictionary structure is like what? So we have curly braces, and within that we will have key value pairs, right? Now values can be duplicate, right? Values can
Yes,
be
ma'am.
duplicates or unique. But keys are supposed to be always unique, right? Now in case of dictionary, if I want to find all the keys, right, and put them in a list, then what function do we call?
Keys of that particular keys of D.
So keys of D will give me a list of all the keys in that particular dictionary. So in this list, are the keys in any particular order?
No, ma'am, random order.
Random order, right? Now let's come to list. So what are the basic list operations? So we have first, then last. What are the other two?
Rest and init.
Rest and init. Now in case of rest, which element do we eliminate?
First,
First element, right? In case of init, we will eliminate the last element. Okay. Now, in case if I want to traverse through a list, right? If I want to traverse through all the elements in a list, what is the piece of code that I'll write? If I have a list cell, I want to go through all the elements.
for each x in L.
For each x in L. So using for each block, we can traverse through a list. Now, in case of dictionary, if I want to go through the keys, I can do the same by writing for each I in keys of D, right? Like that, I can go through the keys. Now, what are nested dictionaries?
Dictionary within dictionary.
So if I have a dictionary D and I write like this, that means actual dictionary structure is like, so for every X, right, there
We
is
have
another
another
dictionary.
dictionary with
So
key
here
Y.
X is the outer key, right? X is the outer key. Now within this also I have one more key value pair. This is the inner key. This is nested dictionary. So these are all the basic things about lists and dictionary. Now, what is insertion sorting? So when I do insertion sort, can I sort the elements without using a separate list or just the list that is given to me? How many lists do I need?
We need one more list.
So we need one more empty list, right? And
Yes,
what
ma'am.
is the procedure that I will go through all the elements that are in sorted order, right? So we have that sorted list insert procedure. So if I have a sorted list and I want to insert an element X in it, then what is the procedure? First, I will have to check that if X is less than the elements in the list, right? So I will go through one by one element in the list and I'll check that if X is less than or equal to, right? So if X is less than that some particular element A, then I will insert X just before A. Now what happens if that X element is greater than all of the elements in the list?
Last is condition get true. If not inserted, it will get appended at last.
Correct. So if that less than equal to condition doesn't satisfy for any of the values, then X will get inserted at the end of the list. And all of the other elements will be inserted at the beginning of the new list, right? So these are basically all just a very brief summary of the concepts from weeks 5 to 8. Now let's try some questions. After that, if you have any more doubts, I'll take that. Okay. So this is the first question. Is it visible? See.
Yes, ma'am.
So read the question. It is saying what will be the value of M list at the end of the given pseudocode. So this is L is a given list. Okay, this is what? This is the list of lists. Correct. So M list is an empty list. Now it is saying that for each element in L. So when I say each element, that means I will mean one of the inner lists, right? Entire list. Now Z will be equal to do something element. This do something is what? It is a procedure. What is element?
Argument.
Argument or parameter. So it is saying that for each of these elements, that is each of these inner lists, I will call this do something procedure with element as, that is this list as the argument. So now control will shift to the procedure itself. Let's see what it is happening here. Whatever list we are passing as argument, take it as X. So small a will be storing init of X. That means everything except the last element in that list. And it will return first of A. Okay, so now let's break down this question. So for the first list in this question, first inner list, 100 and A. Right, so this will be the first parameter of do something procedure. Okay. So if I do init, that means which element will be eliminated?
A.
A will be eliminated. So A will contain, small a will contain what? 1 and 100. And when I do return first of A, it will return just this 1,
1.
right? Now this will be returned where? To Z, right? And after that, that 1 will be appended to M list. Okay. Wait. Yeah, okay. So 1 will be appended to M list. So 1 will be appended in the form of what?
List.
List,
As an,
ma'am.
as an element in the list, right?
Element in
Yes,
the
ma'am.
So M list after first iteration contains 1. Now second iteration will pick up this second list here for each element in L. So second list now comes. So B will be eliminated again in the do something procedure. So which element will be added again? 2.
2.
So like this, when I go through all of the elements, only the first ones will be added to M list. Right? So M list at the end of execution should look like this. Correct? Clear?
Yes, ma'am.
So option C is the answer. Okay. Is this code clear for everyone? Right.
Yes.
Okay.
Yes, ma'am.
All right. So second question is this. I have around 16 questions. So after solving all of them, your concepts should be all clear. Okay. So this statement is saying that the following pseudocode is executed using words dataset. Words dataset contains what? Each of the cards contain what? What are the information present?
Sequence number, part of speech, letter count.
Sequence number, part of speech, letter count, and the word itself, right?
Yes, ma'am.
So these are the elements we have in each of the cards in words dataset. It is saying explode X is a procedure which returns the list of the letters in the word X. So if explode sweet, if I do sweet is the word, then this list will be returned. All of the elements broken down. That's it. So what will count represent at the end? Now let's go through the code. Count is first initialized to 0. Letter list is an empty list. So while table 1 has more rows, now we are going through the entire dataset, words dataset. So you read each of the rows and then letter list. In this empty list, you're calling the procedure explode word. Right? So whatever the first word is, that will be separated into all of the letters and it will be stored in this letter list. Okay. Now, next step it is saying count plus check something letter list. So let's say that this is the first word is sweet. Okay. So first word is sweet. That means letter list right now contains what? This thing. Right.
Yes, ma'am.
So after that, when I go to count and this check something procedure is called. So now control will shift to here. So this list is what now? This. The current letter list is passed as argument. So inside check something we're doing last letter. Okay, last letter is a variable. Inside that we are storing first of L. First of L is in this case it is S, right? Rest list is containing rest of L. That means everything up to this part. So now for each letter in rest list, that means each letter in everything except the first element. If the letter is equal to the last letter, that means if we find any match with the first letter, right, then I will return 0. If there is no match, so this for each block is starting here and ending here, right? So for every one of these letters, that is WEET, it will go into this loop for each block. Okay, and it will check with the last letter, that is S. So if any match is found, 0 will be returned. Okay, and if no match is found, then so what will happen? So first W comes, right? So S is equal to W? No. That means I won't enter this if block. No. So I will come to this part. Now last letter will be changed to the current letter, that is W. Right. So for first iteration, we are comparing W with S. After that, since it is not a match, so last letter is now updated to W. Now next iteration, we are picking up E. And now the comparison will happen between E and W. Okay. Again, no match is found. So last letter is now updated to what? What will be last
E,
letter
ma'am.
now?
E.
E. Right. Now again, next letter you pick up is one more E. So at this point, I will find a match. E equals to E. So I will return 0. So when will this procedure return 1?
When the consecutive letters are not same.
When there are no two consecutive same letters. Correct. Right. So in case of all such words which have no two consecutive same letters or pairs of consecutive letters that are not same, in that case only it will return 1. In all other cases, it will return 0. Right. So count will be incremented for which words? Where there are no two consecutive letters which are same. Now check the options. Which option is correct? See. Number of words with at most two consecutive occurrences of the same letter. With at least two consecutive occurrences of the same letter. Exactly two consecutive occurrences or no consecutive occurrences. Which one?
No consecutive.
No consecutive occurrence.
This
No
one, right? So
consecutive.
because even if we find 1, it will return 0 at that point. Count won't be incremented. So any confusion in this? Anyone? Now this one. It is saying the following pseudocode is executed using Olympics dataset. The template of Olympics dataset is attached in the beginning of this. That is, it was part of our PYQ, right? So the Olympics dataset is given. It will be given to you, like the basic template. So what will B represent at the end of execution? It is asking. So let's just go through the code first. D is an empty dictionary. Okay, so while table 1 has more rows, so we are going through the Olympics dataset now. So Olympic dataset contains what? Any idea? It contains information about players, their medals, right? How
Right.
many medals each player has won, in which year, these things. So we will go through each of those cards in Olympics dataset. Now D will be, so D this empty dictionary. For every iteration, it will call the update dictionary procedure. With what? It will call with argument itself, the dictionary D, and the sports that this particular person plays, whose card we are now using. Okay. So let's say they play football. So D comma football, it will be like that. Then move X to table 2. Okay, so we will call this procedure for every single card in the Olympics dataset. So every time we come to this line, update dict, so it will go to here, control shifts to the process itself. Now here it is checking that whether this sport A, whatever the sport is, whether it is already a key of dictionary D. This sport has already been updated as a key in this dictionary or not. If it is a key, then we will just increment it. That means one more person's card has been found who is playing this particular sport. But if it is not a key, then we will assign it 1. It means we'll create a key for this particular sport and assign it the value 1. That means one person's card has been found who is playing this sport. Right. So what are the keys in this dictionary D?
Different sports.
Different sports. So the work of this procedure update dictionary is just that it will increase the count for the key for each individual keys. Okay, every time a particular card is picked, which is of a person playing a particular sport. So for that sport, the key value will be increased by 1. Okay. Now after that is done, so it will come back to here only, right? This return D. So at the end of execution of this entire while loop, it means we have gone through all of the cards in the data set. So at this point, the dictionary D will look like some sport S1 and maybe 3 people play it, some sport S2, 4 people play it, like this. Right. After this, we have one more variable B. Now in B, we are calling a separate procedure called find value D, where D is taken as the argument. Now what is this find value procedure doing? So now the control will shift to here. So here we have some variable V which is set to some very high value, right? That we know that why we have set this to this very big value is because we want to make sure that this V variable holds such a value which is greater than all the values in this D dictionary, right? Not the keys, the values in this D dictionary. Now why we are doing that? So after this C, there is a for each block. So here it is saying for each A in keys of D. So each A is a different sport, right? Now for every unique sport, we will check that the number of people that play that sport, is that less than V? If it is less than V, then you will update V to that value. So let's say for this, so let's say this is the dictionary. So for this, when I call this find value procedure with D dictionary as key and this D is the dictionary, let's say. So for first key, that is S1. So what is the value? 3. 3 is less than this V value, right? So at this
Yes,
point,
sir.
V will be assigned what? 3, right?
3.
Now next iteration, I will go to S2 sport. Now it is 4. 4 people are playing this sport. So is 4 less than V now? No. 4 is not less than 3. So V will not be updated. Now when I go to S3 and one person plays, so 1 is less than 3. So now V will be updated to
1.
1. So at the end of execution, that is after I have gone through the entire dictionary D, all the keys, then V will contain what? The least number of players who play any sport, any particular sport.
Yes,
So
sir.
will contain the number of players that is least in any sport. Okay, in any one of the sports. So that V will be returned. That least number of players will be returned. So the question is asking that what will B represent at the end of execution? So this V value is returned to B only. So which of the options are correct? There is one more option. Yeah. So total count of players in the Olympics dataset, number of players in each sport, number of frequent sports, number of players in the least frequent sport. Which one?
Option D, ma'am.
Option D. Okay, any doubt in this? Okay. Now let's go through this. So this is saying that following pseudocode is executed using, again, words dataset. So what will count2 represent at the end of execution? Count2 is some variable in this code.
Sorry, can you show the answer for question, the previous question? Okay, thank you.
Yeah, this one. Okay, so D is an empty dictionary initially. Now A is a variable we are initializing to 0, total we are initializing to 0, count we are initializing to 0. Okay, all three are initialized to 0. Now while table 1 has more rows, so we'll go through all the rows in words dataset. Now after you pick one card, so you will add the letter count. Every card has the letter count of that word in that card, right? So you'll add the letter count to this total variable. So total will contain, at the end of this while loop, total will contain what? Sum of letter counts of all words.
Total let's count of the
Total
data
letter
set.
count. Sorry. Count will represent what? Number of cards in the
Number
data
of
set,
cards.
right?
Number of words.
Number of words, number of cards. Okay. Next. Now inside this while loop, once we pick a card, we add the letter count to total, we add 1 to, that is, we increment count. After that, we have this if condition. We check that whether in dictionary D, that is this empty dictionary we initialized at first, we check that whether that word is present in D or not. If it is present, then you just increment it by 1, the frequency of it by 1. So this is D is what? It is a nested dictionary, right? Nested
Yes, sir.
dictionary, why? So within this, we have first one word, that is the outer key. And inside that, we have one more key called frequency. Right. So this is frequency is keeping track of what? How many times that word has occurred. Right. How many times that word is in the data set. That will be kept track in frequency. So if that word is already a key of D, that means once that word has already occurred. Right. So it is, let's say some word has occurred. Let's say the is the word that has occurred 1. Now it comes again. So we'll increment the frequency by 1. It will become 2 now. Now if I get some unique word that hasn't occurred till now, so in that case, we have to create the key. So first we'll create the outer key. So X word is the outer key, that is for that unique word that has occurred for the first time now. For that, you will create a key and the value will be what? An empty dictionary.
The dictionary.
Right. So within that empty dictionary, now we have to create the inner key.
Inner key.
So that is frequency. And since this is the first occurrence of this word, so we'll assign the value 1. Right. And there is one more key also. That is letter count. So
It's letter count.
frequency is 1 and one more key is letter count. In that, we will store whatever X is the letter count of that particular word. Okay. So for every word in our dataset, we will have an entry in the dictionary D. And against that entry, we will have another nested dictionary in which we are storing 2 more keys, frequency and letter count. Now, frequency will keep on updating every time that word occurs, right? So this part will happen. This is all happening within the while loop. Okay. After this, we have one more if statement. So here it is checking that if the frequency of that word, the frequency of every word that we are picking, the cards that we are picking, right? So we are checking that if that word's frequency is greater than A is initialized to 0. So obviously every time a word occurs, like let's say the first word that we are dealing with. So every time that word occurs, the frequency is incremented. So the first time the word occurs, frequency is 1. So obviously it will be greater than A always, right? So every
Yes.
time we will do this comparison that whether frequency is greater than A. So if it is greater, then you will update A's value to that particular frequency. So now A becomes 1. Now if some other word comes along whose frequency is 2, that it has occurred 2 times. So that time A's value will be updated to 2. So if I do like this, then at the end A will carry what? The highest frequency word.
Maximum frequency or most frequent word.
Right. So it will contain the maximum frequency of the word that has occurred the most number of times, right? The frequency of that word. So A will contain that. Now, after this while loop ends here, Then we have a variable called average, in which we are storing total by count. That means average letter count of the entire data set. Right. Then we have one more variable, count1 and count2, both are set to 0. Now there is a for each block. It is saying for each k in keys of D. So what are the keys of D?
Distinct words.
Distinct words. So for each word, now we will check if DK frequency means the frequency of that word. So at this point, our dictionary is fully populated, right? Every word against that, we have the frequency, how many times it has occurred, and what is the letter count. And we also, A contains what? The maximum frequency. So we will check for every word if the frequency matches with A. That is that word the maximum frequency word? That is the word that has occurred the maximum number of times. If so, then we will come to the nested if and check whether the letter count is greater than equal to average letter count. So there might be more than one words, right, which have occurred the maximum number of times.
Yes,
So
ma'am.
for each of those words, we will check whether the letter count is greater than equal to average letter count or not. If it is so, if both these conditions are true, then we will increment count1. Okay. And if it is the maximum frequency word, but the letter count is not greater than equal to average letter count, then we will increment count2.
Count 2.
So question is asking what will count2 represent? So count2 will represent those words which have the maximum frequency but have a letter count less than average.
Less than average letter count.
Right. So which of the options? Option A.
First.
Maximum frequency words with letter count less than average letter count. Okay, this code is clear also. Now this one. Okay, you check this for just 2 minutes. Give me 2 minutes. I'll be back. Okay, so you went through the code. Let's see. I'm audible, right?
Yes, ma'am.
So here it is saying that LA is a sorted list of integers in ascending order. So X is an integer. Okay. Now the procedure inserts the element X into the list LA. So X is such an element which we want to insert in LA. Okay. In such a way that the list remains sorted. So this is basically which procedure? Sorted list insert procedure. So but the procedure may have some mistakes. You have to identify those mistakes. Okay, that's why I told you to see the code. So we are going to assume that all the statements that are not in our options are free of errors. So first, just go through the code. Okay, then we will go to the option. So let's say I have this list. This is a sorted list, right? Now, if I want to insert here 11, X is 11. So now let's go through this code and see what's wrong. So this is LA and this is X. First, they're saying LB is initially an empty list that we are initializing. Flag is a variable that is set to true. So for each A in LA, that means for every element in LA, if flag means When will this be, when can I enter this block?
If flag is true.
If flag is true. Okay. So if flag is true, so flag is initially true. So for the first iteration, it's fine. I can enter. Now I will check whether x is less than equal to a. So 11 is less than equal to 7? No. So will I enter this block?
No, ma'am.
No. So I can just skip this part and come to this line. So in LB list, I am entering 11. Now is this correct?
No, ma'am.
I should enter 7, right?
7. A. LB
So,
plus A.
right. So this line is wrong. Instead of x, this should be a.
A.
Now again let's check for the next some iteration. Let's say where we come to
Ma'am,
12.
it should be first of LA or A?
Only a.
It is A.
Okay.
Oh,
Because we are checking
A.
from the first element only.
A. Yeah.
Okay. So now let's see where if I did the comparison, that means if I reach this element 12 and now I have to compare with x. Okay. So for each a in LA, here a is now 12. So if flag, let's say flag is true at this point also. Okay, because we never entered this block. So if x is less than equal to a, so at this point 11 is less than 12. So I can enter this here. Now inside this it is saying LB plus x. Okay. So after that it is saying we'll set flag to false. So any error you can see here?
It will be X plus LB.
You are saying it will be x plus LB. Now check the options once. I'll tell you which lines are wrong. A, D and E are wrong. So it is saying that line 2. So why am I saying that line 2 is wrong? Any idea why line 2 is said to be wrong?
Ma'am, line 2 is correct, I guess.
It is saying LB should be initialized as LA. This should be initialized as the list itself.
LB is LB is a copy of LA. If we do
It is
No,
that,
saying,
ma'am. If we do that,
but then
will
if
be
we
wrong.
insert, then it will be wrong. I think this is wrong. Line 2, I think is correct. Maybe the answer here is given as wrong. Because then we will be inserting more elements in duplicate elements will be there. This line is wrong. 11 is wrong for sure. But up to this, I think everything is okay. LB should be an empty list only. We can check the sorted list insert procedure also. There also we initialize it as an empty list only. Okay, fine. Let's see what happens. What other lines are wrong. So it is saying that this line is also wrong. X
Line
should be
14 is
appended.
wrong.
X should be appended as list P. Right. This line. Now, why is this line wrong? Because once I get this, okay, once this X is inserted, right? That means LB plus X. After that, flag is set to what? False.
False.
Right. So next, when I go for the next A, that is 14. Okay. Now at this point, so here now for each A in LA, now when I check if flag, so this will be false. So I cannot enter this entire thing. Right. So what will I do? I have to go to,
Come to line 11.
I have to come to line 11, but this line is again wrong. Right. So considering that it is corrected, that A is now being appended, 14 will be added to the list. Okay, now what happens if X was 19? So in that case, this condition will never be true, right?
Yes,
For
ma'am.
this particular list. So if it is never true, that means flag will always remain what? True. Because I cannot enter this block and I cannot set flag to false.
Yes, ma'am.
So that means if I have such an element that I want to insert in a sorted list, which is greater than all the elements that are present in the list, in that case, flag will remain true throughout this for each block, for every iteration. Now, after I have gone through all of the elements and inserted them in LB, then I will come to this line 13 and check if flag. Right, so flag is still true because it was never set to false. So at this point, I will come to this if block, enter it, and it is saying append A to LB. So this should be X,
We
right?
append X here, right, at the end.
So X should be appended at the end. So line 11 and line 14 have errors. Line 2, I think, is correct. There is nothing wrong here. Why would I want a copy of LA? So this one, I think only these two lines. Okay, anyone who has a confusion in this procedure?
Ma'am, if we create a copy of LA in LB,
Hmm.
then still this procedure goes well. Like where?
In that case, what will happen? See, in that case, LB is not an empty list. Okay.
Okay.
So LB is no longer empty. So it
Empty
already
list.
contains all these elements.
Yes, ma'am.
So again, it is comparing with the same elements and adding the same elements again in LB. So LB will have a copy of all the elements now, except for X. So X will be present once in LB, but all the other elements will have duplicates. It is simply the same procedure will run, except all these elements are already present in LB. So instead of them being present, we will still add them to the LB list again. That's why I think LB
Ma'am,
should be initialized as empty.
any of the A is not being appended in LB.
Yeah,
If
ma'am. Sorry,
No,
yeah.
that is the wrong line here. No? So in line 11, it should be appended. The A's should be appended here. That's the mistake.
no, if
Even X, it will be only one element that will be added, ma'am. So I think that's why we need to initialize that with LA.
Okay, so in the context that this code is wrong only. So in that context, you're saying that LB should be initialized as LA.
Yes,
yes,
ma'am.
ma'am.
Okay, so in the wrong code context, if we see, so if LB is this list, this 7, 9, 12, 14, 18, right?
Yes, ma'am.
Okay, let's say this is LB. So in that case, again, we will go through all of them, and none of these, none of the A values will be added to this list because of this line, since it is just appending X. Yeah, this will also work then.
Yes.
Then only X will be appended.
Correct.
But
Yeah,
that
yes,
will
ma'am.
also not be appended because since that is
error.
not happening.
Yeah, that's
Yeah,
right.
that's the
Yes,
error
ma'am.
statement.
And 14 still remains wrong.
Yeah. So 11 and 14 are definitely wrong, but
Yes, ma'am.
this one I still have some ambiguity. I don't think it should be considered wrong. Because in the actual procedure, this is the correct code. It should be initialized as an empty list. But definitely these two lines are wrong. So if we see from a wrong code context, then this will work. If I initialize LB as this. But in spite of that, never the X value will never be appended. Okay. Alright, this is
Ma'am,
just to.
ma'am, will you go up? If you take LB as an empty list,
Hmm.
then you will have to make 7 wrong as well, because how are you going to add A elements to LB? Which of the steps?
That's the wrong step, no? The A element should be added in step 11. That's the mistake here. In the correct code, this line should be appending the A value. Okay.
You are saying that 7 is also wrong. It should be A here.
No.
A should be appended.
No, see. 7 is correct. Why?
Okay.
Because if X is less than the element that we are comparing it with, if X is less than or equal to it, then I can
Yeah.
append X at that point, right? So this line is correct. If I
Yes.
wanted to append 11 and A is 12 currently, so 11 is less than 12, I can append 11 before 12. This is correct. This line is wrong because none of the actual A values are getting appended. This should not be LV plus plus X. It should be LV plus plus A. That is, all the elements that are less than X should come before X, right? So that append will happen in line 11. So this is one mistake. And again, if X is such an element which is greater than all the elements in the existing list, then that should be appended at the end, which is happening in this if block. But this code is also wrong because instead of A, it should be X. Okay. So this procedure, we will check this once with the sorted list insert procedure, okay, that we have in our slides. But as far as I think that this is correct, this line. Let's see one more time. Okay. See, this one is saying that, okay, this is a good question. Now, A is dictionary, in this dictionary, A, B, and C are keys. Okay. So A has list as values, B has list as values, C has an element as a value. So the following procedure, do something, is executed on this dictionary. So instead of X, dictionary is passed as parameter. So what does the procedure do something return? So do something dictionary. Okay. Now for each I in keys of dictionary, return dictionary I. That means the value that is stored against that key. So which value will be returned? This is an MSQ. Okay.
The first, and then it will stop. Means 6, what was that? 1, 2, 3, 4, 5, and it will stop because return stops the.
We are saying that option B should be correct.
Yes, I think so.
Anyone else?
Ma'am, it can return all of the options. Once could you show the D option? No, D option is wrong. ABC is always right.
Still
I
you'll get
feel.
it wrong. Why? Because you didn't check properly. B contains 6, 7, 8, 9. Option A is just 6, 7, 9. That means this is wrong. B and C are correct. Why? Because we don't know that in which order the keys are
Order
present in the
of the
dictionary.
keys.
Yeah. So we don't know that. Any of them could come. Right. So either it could be 1, 2, 3, 4, 5, or it could be 6, 7, 8, 9, or it could be 19. But it is intentionally the first option is given wrong in this way. The 8 is omitted so that you make that mistake. Okay. Because if it returns the value for B, it should return this entire list 6, 7, 8, 9. Right. So B and C are correct options here. So it can return 1, 2, 3, 4, 5. It can return 19. And actually it can return 6, 7, 8, 9 also.
Only one
Yes.
of it, right?
Yeah, only one will be returned, but we don't know which one. So we are saying may return this. So both B and C options are correct. Yes.
Ma'am, a small query. Like since even recursion is there in this exam, so for recursion we don't know it will be directly said as return of something will be returned right over there.
In recursion, when there is a return statement, it returns the value to the last procedure call. Okay. And it will backtrack like that till you return back to the original, that is mother procedure.
And that is where we are having, I mean, at least I am having most problems in recursion and DFS, not these. Means that is the point we want to stress on.
Yes, yes. So recursive, those things, what did you say? Drafts. That part.
DFS and recursion.
Yeah, DFS, all of that will be covered in that 9 to 12 revision session. Okay. So in this session, we are covering 5 to 8. So only the topics from 5 to 8 I've taken questions on. So next session will be on 9 to 12. So there will be all the questions from BFS, DFS, all that. Okay. Recursion, see. If you are having problem in recursion, I would say that, okay, you can go through some basic codes that are, there in recursive functions, like the factorial problem you can do. Okay, that is one of the best problems for solving recursion. There is also that HCF problem, right? So recursion, why people have difficulty in that topic is because they lose the track of the flow of the program. Okay. So what you are going to do is that every time the procedure is being called, okay, terminate the current procedure wherever you are. Wherever the procedure is being called, you move again to the new procedure call. Okay. Like this, you will continue until there are no more recursive calls. That is, you have made the base condition. For factorial, that is what? What is the base condition?
0 is equal to 1. Means
Factorial 0 is 1. Yes. So once your n becomes 0, so you know that that is base condition, so you can stop. No more recursive call. Now that you stop, so that particular procedure call in which you are right now, that is returning something. So where will it return that value? To the last procedure call. That is when n was 1. So you are going to do 1 into 1. Right. Then again, that procedure where n is 1, that return value will return to where? Where n was 2, the previous call.
and so on.
So 2 into 1. Like this, you will backtrack till you reach the last, that is the first call actually, where n was whatever, let's say 5. So at that point, since you're backtracking, so it will be 1 into 2 into 3 into 4 into 5, like this. Recursion is very easy. Okay, just do a few more examples.
When we are backtracking, where these values of the first procedure call will be somewhere stored or something like that?
Yes, because every time you're calling the procedure, you're assigning the values to some variables, no? They are always stored. Whatever you are returning, that value, where do you return the value? Where the procedure was called, right? Return value always goes where? Where the function was called. Like in the previous case, we said, if I say Z and then do something procedure, right? And pass some access parameter. So whatever this do something returns, that will be returned to this Z. It will be stored in Z. Okay. Then again, in the other procedure, like where you returned this, that procedure will also return something that will again be returned to where that procedure was called. Wherever the procedure is being called, that's where the value will be stored when it's returned.
But in the first process, when we are going return calling again and reaching to the base value, at that time where the result will be stored of that procedure, because there is
Till now, till now, have you generated any result? Think of it. If you're calling the procedures and you go on till you reach the base case, so till then, you haven't actually generated any value because you never completed any procedure, right? You just kept on calling the next one. So you will actually start evaluating from the base case. So once you reach that base case procedure where base case is satisfying, there you will start evaluating. And as soon as you evaluate, you're returning that evaluated value to the last procedure. Then again do the same calculation there, again return that value to the previous one. So it just flows backwards till you reach the actual first procedure call. So the main value will be stored in the first procedure call only. That only will have the actual result. Okay, I will again go through that factorial function if you want. Okay, should we do that?
Yeah, please.
Okay. Okay, first can I just finish the questions I have here for 5 to 8, then I'll take it.
Yeah,
Okay?
after finishing this, you just take that.
Yeah, okay, we'll take one example of recursion. Okay, this question is clear to everyone why option A is wrong. Option A and D are wrong.
Yes.
I mean, previous question, why 19 is not in angle brackets?
Because 19 is a simple element. It is not in a list or anything, no?
Okay.
Okay. Now this one. So the following procedure is executed using library dataset. Library dataset contains what? Author information, book information, when it was published, all this, right? Now it is saying that P is a list of authors who have written books in English. Okay, P is a list which is containing author names who have written books in English. Now dictionary X, this stores the number of books having at least 100 pages in evergreen publishers by author X. That means dictionary X means what? Dictionary has a key called X. So this X is some author who has published some books which have at least 100 pages under evergreen publishers. So what are our conditions? That the books should have at least 100 pages and should be under this publisher, right? So what does this dictionary look like? So some author ABC is the key, right? Against him, we are storing whatever is the number of books. Let's say he has written 3 such books which have at least 100 pages and are under evergreen publishers. So ABC 3, some XYZ 2, like this, right? So choose the correct code fragment to replace this. So this is our goal. We need to form this dictionary X. Okay. So first we have an empty dictionary. Now for each author in P is a list of authors who have written books in English. So again, what other condition is there? That the books should be written in what? English. Right. But do we need to check that condition? Because we don't. Because P is already containing only those authors who have written in English. So for each author in P, dictionary author will be set to 0. That means the key will be set in this dictionary. Right. For every author in P, we will have a key in the dictionary and the corresponding value will be set to 0. So initially all values are 0 against all author names in this dictionary. Next, we have a while loop where we are going through this words dataset, I think. No, library dataset. So table 1 has more rows. Read the first row X. Now this part is the code that we have to fill. So let's go to the first option. It is checking if is key dictionary author. That means the part that we have fixed in library dataset. Whoever is the author, is he a key in the dictionary? When will he be a key in dictionary?
Because if he's already stored before.
That will happen when he has written books in English. Right? Because P only contains those authors who have written in English. So if that author that we have fixed is already a key in this dictionary and X dot pages, that means the book that he has written has greater than 100 pages and the publisher is evergreen. Both these conditions are true along with this condition. That is, it is a key. He has written books with pages greater than equal to 100 and publisher is evergreen. If all three conditions are true, then we are going to increment his value by 1 in the dictionary. So is this correct?
Yes.
Correct, right? So library dataset contains information about a single book in a single card, right? An author can have many books. So if an author has written more than one book which satisfies these conditions, that the book is obviously in English because the author list is coming from P, which is a list of authors who have written books in English only. And that the pages are greater than 100, greater than equal to 100 and publisher is evergreen. So every time this happens for an author, the corresponding key value pair, the value will be incremented by 1. So this option is
Ma'am,
correct or not? Yeah.
ma'am, we will miss those books, no, which are not written in English. Because in question, it is telling X shows the number of books having at least 100 pages in evergreen publishers by author
Yes.
X.
Yes. But we are taking these authors from which list? From the P list only. So this
Yes,
part of
ma'am.
the code makes sure that you are not having any, you are not checking for books that are not written in English. We only want those books which are in English and also satisfy the other two conditions. That's why this line is given in the question.
Okay, ma'am.
Okay, we are not checking for other language book. So by that logic, is option A correct?
Yes, it is correct.
Correct.
Yeah.
Correct. So this is MSQ, so I have to check the rest of the options also. So this one is saying that same thing except or condition. This will be false.
False.
Right, so it will take those authors also who have written maybe under some other publisher or less than 100 pages books. Those also will be incremented. Option C is saying there are two variables C and D which are set to false. Okay, now see one thing. Basically, this A and B code that we have in options A and B. Okay, this is the optimized version. So we have just broken down that code and in inserted some new variable just to make it look harder. It is the exact same thing that we are doing here, just broken down the conditions into two parts. See, so C and D are initially false. Now first it is checking that whether author is the key of dictionary and if the pages are greater than equal to 100. If so, then C is set to true. And second, if it's checking that whether the author is the key in the dictionary and publisher is evergreen. If these two are also true together, then D will be set to true. Now this last one, this if is checking C or D. That means if any of them are true, then it will be incremented by 1. But is this true?
No, it is
No,
false.
No, ma'am.
Both
C
of them
and
should
D.
be true, right?
Hmm.
Yes. So it should be C and D. So this option is also wrong. And now this is the exact same thing with AND. So this will be correct. A and D are answers. Okay. So A and D, if you check it, this is the most optimized version of the code. We are writing this code in 2 lines and we are writing this in 10 lines, but same code. Okay. So this question clear for everyone? Right? Shall
Ma'am,
we
a
go to the
small
next?
small query. Dict also contains the authors who have not written in
No.
evergreen, but no, it might contain, right, ma'am? But
Oh,
with a
who
value
are not
0.
written in evergreen. Correct. It will contain all authors who have written in English. But
Yes,
those
ma'am.
authors who haven't written in evergreen publishers or haven't written books having at least 100 pages, for them the value will be 0.
Yes,
Okay,
ma'am.
never
Yeah,
been.
got it. Yeah. Clear, ma'am. Yeah.
So let Z be a row in the words table. Again, words data set. So Z is a single row. That means a single card from that data set. Such that Z dot word is reluctant. So reluctant is the word in that card. So what will be the value of alpha dict T at the end of execution? So let's see what is alpha dict. So alpha dictionary is this dictionary where T, C, A, S. For these 4 letters, the frequency or something is given. Like against them, some values are stored 2, 1, 1, 0. Now alpha dict, next line, it is calling a procedure called update dictionary where the parameters are Z and alpha dict itself. Z is this word. Okay, that means this card basically. So what is this procedure doing? Now control shifts to the procedure definition. So I is 1, X is T. Now we are checking while I is less than equal to Z letter count. What is the letter count of this Z? 9. Reluctant has 9 letters. So we are checking till I is less than equal to 9. As soon as I becomes greater than 9, we'll stop. Okay. So for first iteration, I is 1, fine. Now X will store ith letter of Z dot word. What is the first letter? R. If not is key dictionary X. What is the dictionary? We have taken this dictionary. This has been passed as argument, right? So in this, we are checking whether X is a key or not. So is R a key of alphabet?
No, ma'am.
No. So it is checking that if not is key. So it is not a key. So this whole line turns out to be what? True. Only is key is false. So not of false is true. Right?
Yes.
ma'am.
So we will enter this if block and dict X equals to 1. That means we will create an entry for R. So now alpha dict also has another entry for R, which is 1. Okay. Now, if it was already a key in alpha dictionary, that is, if it was among T, C, A, S, any of these letters, then it will just be incremented. Okay, now I is incremented again. So I is now 2. 2 is also less than equal to 9. So next letter is what? E. For E also, we will have to create a new entry, right? So E will also be set to 1. Similarly, for L, U, both of these will have to create entries because they're not present. L, U, all are set to 1. Now, when I come to T, okay, at this point, I is what? 5, 6. I 6. Sixth letter is T. So, is T a key of dictionary?
Yes.
So, not is key will return false. So, I will go to the else part and just increment the corresponding entry we have for T. So, T becomes what now? 3. Now, again, I is incremented to 7. Next letter is A. A is also a key. So, I will again increment A's entry to 2. Next letter is what? Eighth letter is N. For N, is there an entry? No.
No.
Create 1 and write the value 1 against it. Now, last ninth letter, where I is 9. So, 9 less than equal to 9, fine. So, is T already present? Yes. So, again increment T. It becomes 4. After this, if I increment I again, it becomes 10 and 10 less than equal to 9 violates the condition. So, I'll end the while loop and return the dictionary. So, at this point, it is asking that what will be the value of alpha dict T. That is for the key T, what is the value stored?
Four.
The value is 4. That's the answer. Okay, this is clear?
Yeah.
Okay, now this is a 2-part question. So this is the same code given for the next 2 questions. So M is a list containing element 0. MA is a list of lists. MB is an empty list. MC is an empty list. Okay, now for each A in MA. So what is the first A in MA? This list, 9.
Plus 9.
Then for each B in A, That means inside this list, so what is the first element in that list? 9. 9 is the only element. So B is 9. So we have to append that element to MB in the beginning. Okay. So MB now contains what?
9.
List of 9.
Wait, how many questions are there? Okay, we still have a lot left. Okay, MB will contain 9. Now, it is saying M. Okay, M will be what? Last of MB plus B. So what is last of MB? 9 only?
9.
9 plus 9.
Okay. 9 plus 9 is what? 18.
18.
So M contains 18. Okay. So this is the first iteration of, okay, no, it is not ended yet. It is just the inner loop we did. Now we have to also update MC. So this is for first iteration. So MC is MB plus plus MC. That is appended in the beginning. Right. So this is MC is what? List of lists.
Yes, ma'am.
Right. So MC will contain what? Like this. MB is 18, right? And it is saying MB plus plus MB.
Correct.
That means
Ma'am,
okay,
MB
Ma'am,
is
MB is
9.
9.
M is 18.
oh, I'm sorry. Right. M is 9. M is 18. So this will be 9.
Yes, yes.
Right. MC is 9. But list of lists still, right? Next, it is saying MB is again set to an empty list. So at the end of each iteration, MB will set to an empty list again. So next, second iteration, for each A in MA, what is the next A? This one, 9, 8. So for each A in MA, for each B in A. So now first B is what? 9.
9.
Okay. Now again in MB, we have to insert this. So MB is in now empty. So MB now contains again 9. Right. Now M is last of MB plus B. So again, this is what? 9. Right. So what is last of MB? 9.
9.
Yes. 9 plus 9, 18 again.
So M is again 18. Now come to this line. I'm sorry, no, we will have one more iteration because there are 2 elements here. So again, MB will be, what is the next B? 8. So MB, B plus plus MB. That means MB now changes to 8, 9. Right. And M is last of MB plus B. So what is last of MB again?
9 only.
9.
So what will be
9
M?
plus 8. 17.
Last of MB plus B. That means 9 plus the current B, that is 8. So it will be changed to 17. Now we can go to this line because we have exhausted all the B's in this list. So MC is now MB plus plus MC. That means what will be MC? Was MC reinitialized? No. That means
Stop list.
8, 9 and 9.
9.
Okay, next iteration, third iteration. So now again this list comes. Okay, MB is again reset to empty list. So for each A in MA, this list comes now. Now for each B in this list, the first B is 9. So for that MB is 9. M is last of MB plus B. That means again 18. Now next iteration, what is the next B? 8. So MB is
8, 9.
8.
8, 9.
Yeah, 8, 9.
8, 9 and M is
17.
last of MB plus B, that is 17. Now one more element is there. So again, MB will be
7, 8, 9.
7, 8,
7, 8, 9, and this is MB. And M will be
16.
24.
last of MB plus B. So what is the last we got? 7, and the last of the list is what?
9. So 16.
16. So M is containing 16. Now come out of this inner loop. Now MC will contain what? MB plus plus MC again. That means it will now have 7, 8, 9, then 8, 9, then 9. Correct? And MB is again initialized. So these are the final values of MB, M, and MC. So what will be the value of M at the end of execution? So we found 16. Answer is C. Right? Next question is asking what will be the value of MC? Which one? This one?
A. Yes.
A is the answer. Here, these two questions.
Yes, ma'am.
Okay. Let's go to the next one. Just make sure that you know this list of list. Okay. Don't add a single elements. That can be wrong. That MC addition, right? There many students make that mistake that they don't add the elements in the form of list. They normally add as elements. Okay. Okay. This one, see. The following is executed now on shopping bills dataset. So I have taken a question from every dataset so that you are like, it's a little revision that what the datasets contain. So we have gone through words, library, Olympics, everything, right? So now shopping bills. So what will be the values of D1, D2, D3 present at the end of execution? So D1, D2, D3 are initially empty dictionaries. Now while table 1 has more rows, so we are going through shopping bills dataset. What does each card contain? Customer information, shopping. So there are two different, wait. So we have customer information, sequence number, what category of items they have bought, what is the unit for cost per unit, total cost, right? All of these information is present. So while table 1 has more rows, read the first row, the first card. So D1, in D1 dictionary, we are calling the procedure do something with the arguments X, D1 and SV stores. Okay. So control shifts to here. So X is what? The first card, right? D1 is the dictionary itself and SV stores. So if S is a key of D, that means if SV stores is a key of D1, so for first iteration, will it be a key? No. D1 is empty, right? We have to create the key. So this will be false for first iteration. And else part we will come to and we will create a key for SV stores. And against that key, we will put what? Total bill amount. That means it's the card that we have picked. That card's total bill amount will be the value for this key, SV stores key in D dictionary. Right. Now this dictionary will be returned. Second line D2 will be called. Okay. With the same card.
Ma'am, I
mind.
could not understand the DS is a dictionary or a list or what? I could not get it.
D is a dictionary. Okay.
And
that's why we are checking for keys.
okay, keys and plus Y total bill amount. That means what am I doing? This DS
That
plus.
means if there is already a key present for this S, okay.
Mhm.
That means SV stores in this case. If SV stores is already a key of dictionary D, in
Mhm.
that case, we will just add the total bill amount of that card, whatever card we have currently, to the value that is stored against S. But since I am talking about first iteration, so we just have to create that key with the current total bill amount.
Okay. Means
Okay.
numerically we have to add the total bill amount
Yes,
for.
yes, normally addition. Yes.
Though there are two additions sometimes.
Yeah, this is normal. You have to add the bill amount.
Ma'am,
One second.
Can it be adding, ma'am? It is appending, right?
ma'am, we are appending no all the
But
below.
in this, wait, I think we are storing this as bill amount as a list, right?
Yes, ma'am.
Okay, so if the first card, let's say, has total bill as 100, that means for SV stores, the dictionary will be like So SV stores, against that there is a list in which we will store 100 and then again for the next card. Right, this is appending. So we will append the total bill amount. If SV stores is already a key in dictionary D, then we'll append the total bill amount. Otherwise, we'll initialize the current card as the
And the
first element in the list.
And the appended, it will be a list of lists or a list of elements?
No, list of elements only.
List of elements. Okay, thank you.
Okay. Next, for that same card,
Value will be list of elements, right?
yes, value will be list of elements, that is total bill amounts for all the cards.
Okay.
Okay. Now next, for that same card that we have picked, D2 will again call this same procedure with Big Bazaar. Okay. Now the key has changed from SV stores to Big Bazaar. But Big Bazaar also, I am taking this since as it is the first iteration. So D1, D2, D3 are all empty, right? And DS is what? This D dictionary is also this D2 in this case, which is empty. That means it doesn't have a key. So it has to create a key for Big Bazaar also. And it will store the same amount. That means this is how it looks like. Let's say the card that we have picked, X card, has total bill amount as 100. So for SV stores, we have created one list. Now for Big Bazaar also, we will create one list with the same value. Okay. Again, when D3 is calling the same procedure, so it will create one more key for Sun General and it will again store the same value because all are passing the same card X, right? The total bill amount is same. So this is the first iteration is done. Like this, we will go for all the cards, right?
Ma'am,
So
we
for,
are passing different dictionary, no? Each time.
yes, we are
D1, D.
passing D1, D2, D3. Wait, something is wrong, right? Wait, let me read this properly. Okay, can I start from the beginning again? I think it's got a little.
Yes, ma'am, yes, ma'am.
Okay, let's start from the beginning. So let's say we have the first card is X, total bill amount is 100. Okay. First we have 3 empty dictionaries. Now D1 is calling procedure do something, right? D1 is being passed as dictionary D. Okay, and SV stores is the third argument and this is the card. So first we are checking whether SV stores is a key of D1. Okay. Since it is not, since D1 is empty, so we'll create a key. So at this point, D1 dictionary. Okay, this has a key for SV stores, right? Against this, I have a list which has the total bill amount 100. Now this dictionary will be returned. Next, D2 is calling the same procedure with Big Bazaar. So for D2, again, we are going to create one more key for Big Bazaar. And again, append the, put the same value. Then again, D3 calls this same procedure. And we will make one more key for Sun General, right? But again, the same value in the value part. So like this, we will go for all the cards. Correct. So for all the cards, if I go
One thing I
like this,
could not understand why same value. Different stores, so according to the stores, different total bills of their.
so what is the, let's check the data set one. I don't remember the total, that data set shopping bills. I think there are 2 different types of card in this. No? In shopping bills, how many types of cards are there?
3 time, ma'am. 3 store cards.
Wait, just let me go through the data set one.
It will be for every shop, there will be a dictionary which contains a list of total bill amounts.
Mm.
I mean the step if is key D comma S. I think that's where its stores are
No,
being distinguished.
I think the problem I'm having is that this card has, like the card that we are picking, there are different store informations in them. Like this is one card, right, in shopping mall. Wait,
That's why
can
we're
you
storing irrespective of the shop.
wait, can you see the screen? Or are you still seeing that PDF screen?
PDF screen, ma'am.
PDF screen.
I'll share my entire screen. Okay, now you can see.
Yes,
Yes,
ma'am.
ma'am.
Okay, so this is one card, right? So like here we have one for SB stores. Now this same person might have bought from another shop also, right? So for the same person, there can be different cards for different stores. That's the thing I'm understanding. Like for this person, SB stores is one card here. And for the same person, we have another card from Big Bazaar also. Now let's check the question. So if I have one card, okay. So first row in shopping bills dataset, that means if I pick one card, so that card will be for only a particular shop only, right? This is the part that where we are getting confused, that are there more than one shops in a single card? That is not possible. That a single card has only one shop. That's right.
When we are calling do something specifically, we have given the store names. So accordingly only it will be executed, right?
Yeah, we have given the store name, but see, D1 is initially empty, right? D1 is an empty dictionary. Now, if I pass this card, let's say I take this person, that advice, that person's card. So he has the card from Sun General. Okay. So D1 will be called regardless. So do something will call this procedure with SV stores D1 and his card. Now he has shopped from Sun General. So there is no comparison being made
Yeah.
among the shop names. That's why it is confusing, this question.
Ma'am,
Because,
when the procedure do something starts, Y comma D comma S, so
right,
Y corresponds to X, D corresponds to D3, and S corresponds to store
the
names.
shop names,
And
yes.
and if is key D comma S, so that's where it is stores are being distinguished. D S D comma S. So then we are adding the next
Yeah,
step is taking
but
place.
see this thing. Initially when D1 is empty, right?
Okay.
And we are running this procedure for the first time. Now let's
Yes,
say the
ma'am.
card that I have picked, that person has shopped from Sun General.
Yes,
Okay.
ma'am.
So
Now
D,
D1 is empty, so it is checking whether SV stores is a key of D1 or not. So D1 has
Okay.
no keys, so we have to create a key.
Else we go
So
to
I have,
jump to else step.
yeah, so there it will create a key for SV stores, but the total bill amount that is storing, that is from Sun General, because that person has shopped from that shop only. This is where the problem is.
Ma'am, I didn't get you. Can you please repeat?
Let's say this X card, right? This card that we are
Okay.
passing, this Y. Let's say this belongs to some person ABC who has shopped from Sun General Store. Okay. And his
Ma'am,
total bill amount was 100.
is the
This
first row name?
first row, it is talking about cards, right?
Yes, ma'am.
First
On
row
the
Read
is
the
a
card,
card,
first
ma'am.
row and table
on the
name. So
card,
it is
first row
entire
is
card.
name of the uh, customer or the name of shop.
No, no. When we say that first row in table one, that means one card from the table one, not the rows in the card itself. We say
Okay,
entire
okay,
card
okay,
X.
okay, okay. The pile of the cards.
Yes. So when we say row X, that means one card X. Okay. Now we saw in the actual data set that in every card, a person has shopped from a particular shop. So I'm saying that let's say I picked a card X where the
Okay,
person has shopped from Sun General and the
okay.
total bill is, let's say, 100 rupees.
Yes, ma'am.
But let's say this is the first iteration. Okay. Now when I call
Okay.
the do something procedure for D1, so it will
Yes,
pass
ma'am.
this card as argument, D1 empty dictionary and SV store. Now SV stores is definitely not a key of an empty dictionary, so we'll create a key. But the
Yes,
bill
ma'am.
that we are storing, this bill amount is from Sun General. So here is the problem. So what is the sense of storing such a data? Why will I store some other shop's total amount against some other shop key? This doesn't make sense to me. So this is a very old CYQ. I
Ma'am,
don't.
Yes, ma'am.
can
It's a bit confusing. I think they want us to assume that
ma'am,
SV stores contain.
is key D comma S. So D corresponds to D1 and S
D1,
corresponds to SV stores.
right?
So D angle bracket S. So they are belonging to the same combination like D1 SV store,
Yes,
D2
ma'am. Yeah,
Big
he's
Bazaar,
correct, ma'am. Yeah,
D3 Sun
yeah,
General.
yeah. Only D3 will be written over there. Iski D3.
Wait, let me
we are
understand this. So
comparing
if
both D and S.
no, is key is checking whether S is a key of dictionary D, right? That is, we are
Yes,
checking whether
yes,
SV stores is a key of dictionary D1
D1,
in the
yes,
first iteration.
yes.
So it is not definitely. So we have to create a key,
Okay,
that is this
yes,
one.
ma'am.
But
Yes,
against this, I am storing this value, right? And this value is coming from the card that I have picked. Now that card can be from any store. That's my question. That if
Got
it
it.
is from any
Yeah,
store,
yeah,
But
yes, ma'am. There
then
is
this
this
some
code
data
difference.
is
doesn't make any sense. Yeah.
storing irrespective of the shop.
Yes, it will store, like for every shop, it will
Eh,
store the bills from other shop as well. Total bill
Yes, ma'am.
amount. I think maybe this question is not proper. I mean, there is no meaningful data here.
I think you should always go with the combinations D1 SV store, D2, because that is
No,
how.
if you have to go through what the code is given, right? And the code is evaluating to this. So if I do it like this, in that case, what happens? Like if I do whatever the code is given, in that case, what happens? So let's say the first card is
Then
from
what's
this.
the point of giving D1, D2, D3? They could have given D is equal to 2 something X comma D and the store name. They have given like
Yeah, D1, D2, D3. Why? Because
exhaustively
we
D1
are
as we stores,
checking for,
D2 big.
yeah, we are checking for three different dictionaries. But within those dictionaries, we will have keys for this store. Like in D1, we will only have key for SB stores. In D2, we'll only have key for Big Bazaar, and in D3, we'll only have key for Sun General, right? There is no way that in D1 I will have a key for Big Bazaar because it is never checking for that. The S
But
will remain constant.
the
But
value
the
will be
bill,
all.
but the card that we are picking, that card can be from any store. Now my question is that you are never checking that which store that card is from.
Yes, ma'am, you are
If we
making
don't check
sense.
that,
Yes,
yeah, if
ma'am.
we don't check that, then we cannot say properly that which of these dictionaries that card should come under. So I think some statement is missing here. Maybe there should be an if statement in the beginning where we should check the
Yes,
shop name.
ma'am. Yes, ma'am.
So maybe something is missing. So let's skip this question. I'll have to check this with Piyush though. Okay, let's do this one. So this is from your scores dataset. So top chem and top physics. These are lists of cards. Okay, lists of cards having chemistry marks and physics marks greater than 75. So these two are lists which are having cards which have chemistry marks and physics marks greater than 75 respectively. So in top chem we only have those cards which have chemistry greater than 75. In top physics we have those cards which have physics greater than 75. Each element in both lists is a record. That means a row. Okay. The fields in the record are same as the ones in the course table. So what will be the value of the list, this sum list, at the end of execution? So let's go through the code once. So sum list is initially empty for each x in top chem. That means top chem has one card that we are picking, which has definitely marks greater than 75 for chemistry, right? Now for each y in top physics, so we are picking one card from this top physics, this list, which definitely has physics marks greater than 75. Now we are checking the sequence number of these two cards. If the sequence numbers are equal, that means if the two cards are same, and mathematics marks is also greater than 75. What does this mean? That all three subjects marks are greater than 75. Correct. Up to this clear?
Yes, ma'am.
If
Yes,
the
ma'am.
conditions are correct, then we will append that in sum list,
List.
the name of that person. So sum list will contain what? Names of those students who have scored greater than 75 in all three subjects.
All three subjects.
Okay. So option D. This is an easy question. Okay, now trains dataset. So trains is a dictionary with train number as key. Okay. Okay. This question, look carefully. So trains is a dictionary. In this, we have train numbers are the key. Like in this case, an example is given 12281. Mapped to a list of stations that the train runs through. So for example, these are all the stations that this train runs. Okay. So 12281 runs from Bhubaneswar and reaches New Delhi via all these stations that are given. So Bhubaneswar is the first station, New Delhi is the last station, and all the other stations in between. Next entry will be for some other train, and again its entire route, all the stations in the particular order. Okay. So what will L store at the end of execution? So first, stations is an empty dictionary, N is 0, L is an empty list. So for each X in keys of trains, what are the keys of trains?
Train
Train
number.
number.
Train numbers. Okay, so for each of those train numbers, stations is a empty dictionary in which we are calling the update dictionary procedure with that particular train number that we picked. Let's say this 12281 is the first for the first iteration. And stations is empty dictionary. So now control shifts to here. Okay. So here what we are doing for each A in trains of Z. That means Z is what here? The train number. So in trains dictionary, if I put train number as the key, against it, the value is all the list of all the stations that it is going through, right? So now against that entire list, now we are taking each element, that is each station from that list for this particular train number. So for each A in trains of Z, okay, that means for this train number, we are going through each of the stations that it goes through. If not is key D of A, that means if that station is not a key of the stations dictionary, then we will create a key, right? And if it is a key, then we will increment. Okay. But see one thing here. If it is not a key, okay, let's say some train starts from Kolkata. Now, Kolkata is not present in stations dictionary. I'm talking about first iteration where stations is an empty dictionary. So no keys are there. So I have to create a key for Kolkata, right? Because this part will return true, not is key. So you create a key and you put the value 0 there. And then after this, you increment the value to 1 because Kolkata has occurred once. So we have to increment it to 1. Understood? So as soon as you create a new key, its value will be incremented by 1. Because this statement will always execute in this loop, right? Because this does not come under any if statement. It is always going to execute. So like this, if I go for a particular train, okay, for this 12281, let's do with this example only. So Bhubaneswar is the first station. So stations is initially empty. So Bhubaneswar is not a key of stations, correct? So we have to create a key. So DA, that means D Bhubaneswar is set to 0. Okay. What is this D? This is basically that stations dictionary only. Okay. Now I have to increment that value by 1. So it becomes 1. Next station that we have is Balasore. So for next iteration of this for each block, one more key I have to create in stations dictionary for Balasore. That will also be eventually set to 1. So for every one of these stations, I will create one key, right? And I will set it to 1. So this happened for one particular train. Now, once this is done, this updated stations dictionary will be returned. Where? Here. And in the next iteration, we will pick a different train number. And again, repeat the exact same procedure. That means once I have gone through all the train numbers, the stations dictionary will contain what? Names of all unique stations as keys. And correspondingly, the value will be how many times that station has been crossed by all these trains, right? That means how many times?
One less than time. One less than the time we have counted.
Why one
Because
less?
first time we are initiating with is we are initiating to
You're
0.
initiating with 0, but that time also you're incrementing to 1. You
Oh,
have to
right,
execute this
right
way.
in the next step, right?
Yes. So after it is done for all the trains in my data set, so the stations dictionary will contain keys as unique station names, and corresponding value will be how many times
Number
those
of
stations
times.
have occurred in the routes of the trains. Right.
Yes, ma'am.
Now, after that is done, you will come to line 6. So for each Y in keys of stations. So keys of stations we know are what? Unique station names. So we will check if station Y, that means let's say for some particular station Kolkata, whatever is the value stored against that, if that is equal to n, what is n in the beginning? 0.
0.
So obviously if we have an entry for a station, the value will not be 0. Correct?
Correct.
So in that case, I will go to this if I cannot enter this. So stations Y is greater than n. Okay, so even if that station is only present in the route of one train, then also the value will be 1, which is greater than 0. So L is an empty list which will now contain what?
That particular
Y is
station.
that particular station. And N will be stations of Y. That means the number of times it occurs. That means the value that is stored against that station in the station's dictionary. So if it is 1, then N will become 1. So like this, we have to check for all the stations. And for every station, every time we find a value that is greater than n, we will change the value of n to that value, and in L we will store that particular station name. So what is the use of all this? So what will n store at the end? The name, the frequency,
maximum number of frequent
maximum frequent station.
that is it.
Yes, maximum frequent station, and L will contain the name of that station. Right. So let's see if in option it is present. So list of stations through which maximum number of trains pass. So there can be more than one such station which have maximum frequency, right? In that case, this condition will be true and you will append the name of that station to the list. In any case, all the stations that are present in L list will have the same frequency. That is the maximum frequency. Is it understood?
Can you please repeat the last if part?
Yeah, see.
If stations Y is greater than n.
Let's say in our dictionary, I'm just naming the stations as ABC, okay? So let's say A has frequency 1, B has frequency 2, C has 4, and D also has 4. Let's say only 4 stations I have in my stations dictionary. Now the A, B, C, and D are keys. Okay. So first if we are checking that, let's take the first key, that is A. So stations Y is equal to N. N is initially 0. What is the value stored against A? 1. Is 1 equal to 0? No. So come to the next step. Is 1 greater than 0? Yes. So L will store what? The name of that station, which we are currently dealing with. So right now L is what? A. L is containing A. And N is what? The frequency. So N is now 1. Now next iteration you pick B. Okay. And the corresponding value is 2. So is 2 equal to 1? No. So you again come to the second dip. Is 2 greater than 1? Yes. So now L will contain what? B. And N will be changed to what? 2. Next iteration, check for C. So C is corresponding value is 4. So is 4 equal to 2? No. So come to second one again. So 4 is greater than 2. So L will now contain what? C. And N will be changed to 4. Next iteration you pick D. D is also having 4 frequency. So now is 4 equal to 4? Yes. So I can enter this if. And I have to append D's name. Right. So now L will contain both C and D. So basically L is a list of all the stations having maximum frequency. And N is that maximum frequency. Clear?
Yes, sir.
Everyone, anyone has any doubt in this? Okay. All right. Now this one is saying the following pseudocode is executed using library dataset. Okay. At the end of execution, A stores a dictionary with the author's name as key and the number of books written by him or her as its value. Right. So A is a dictionary where the keys are what? Author's name and the number of books written by them at the value. But the code may have mistakes. So we have to identify them. Okay. So check. A is an empty dictionary. In this, my goal is to have unique author names and against that, the number of books as values. So read the first row. Now, first row will be what? I will get the author name from there. So I'm checking that the card that I pick, whoever is the author, if that author is already present as a key in a dictionary or not. Okay. So if he is not present, then not is key will return true or false.
True.
If he is not present, then it will return true. That means I have to create an entry, right?
So line number 4 is a mistake.
That means either this is a mistake or these two have to be exchanged, right? Because if it is not a key, then only I want to create a key, right? I won't increment. I will increment when it is already a key. So which lines are mistake? Now, for this particular question, if you go through the options, it will be easier to discern. The first option is saying replacing the condition in line 4 with the statement given below. That is, if I say is key, instead of not is key, if I write is key. That means if it is a key, then I will increment. Otherwise, I will create a key. So that will fix the code, correct?
Yes.
Okay, so option A is correct. Second option is saying replacing the statements given from line 4 to 9 with statements given below. 4 to 9 means up to this part, up to this part. So what are the statements? This. That is, it is saying if not key. Okay, if it is not a key, then you set that to 0 and then increment it.
Yeah, ma'am, it's possible.
This is also correct. Now, third option is saying interchanging lines 5 and 8. So 5 is this line, 8 is this line. So if I interchange them, then also it is correct. For not is key, if I put this value, then it will be correct. That is, I'm creating a key and the frequency is set to 1.
Yes.
So option C is also correct. Now, option D is saying replacing statements given from 4 to 9 with these statements. So it is saying if not is key, then you create a key, but the frequency is set to 0. As soon as you find the key, it should be set to 1, right? That means that author has one book. So it should be set to 1. So this one is wrong. So answer A, B, and C are correct. Okay. Is this clear?
Ma'am, option C, it is changing like how many lines, ma'am? Like
it is changing, it is interchanging 5 and 8.
no. Oh, sorry, option B I wanted to ask.
Okay, this one. It is
Yes,
from saying from line 4 to
4
9.
to 9. So 5 lines, right?
That means this. All of this. Wait a second. Okay. Yeah. Yeah. So for these 6 lines, it is saying that we have to exchange with this part. Okay. So if I do that, if it is not a key, okay, in that case, I will create one and increment. And if it is a key, then I will just increment.
No, ma'am, the other 2 lines which are like empty lines, right?
No, that is fine. That is fine. You don't have to worry about that. I am just taking out this bit of code and entering this bit. It doesn't mean that the number of lines have to be same. It can be lesser number of lines or more. I'm just taking out a part of the code and replacing it with some other code. Okay, number of lines is not a factor.
Okay, ma'am.
In this case, what will happen that if some card I find that the author is not a key, then I will create a key and increment it. And if the author is already a key, then I will not enter this block. I will just normally increment. Okay. So all 3 options are correct except D.
I mean, in option D, it will give that
It will
doubt
give
I
error.
was having earlier.
Yes, it will give one less.
Number of books, one less than the actual.
Correct. Because the first one is set to 0, that's why.
Okay, thank you.
Okay. So I guess 1 or 2 more are left. Following pseudocode is from words dataset. What will count represent? Count is initially 0. V list is an empty list. N list is an empty list. So while table 1 has more rows, read the first row X in table 1. That is from words dataset. We are reading a card. We are checking if the part of speech of that card is noun. Okay, if it is noun, then in n list we will append the sequence number of that card. If the part of speech is verb, then in v list we will append the sequence number. Okay, like this, we will populate n list and v list with all the cards that we are going to go through. Okay, so at the end of execution of this while loop, n list and v list will contain sequence numbers of those cards which are either nouns or verbs, right? Now after that you come to line 13. Okay. Yeah. So here we are checking for each I in n list. That means each sequence number in n list we are checking. If that I, that particular sequence number, one less than that. Okay. Let's say in n list the first sequence number is 5. Okay. So we are checking that whether 4 is a member of v list or not, or 6 is a member of v list or not. That means the sequence number just before it and just after it. We are checking that either those two sequence numbers are the members of the v list, that is the verb list, or not. If any of these are true, that is either 4 is a verb or 6 is a verb or both are verbs, in that case count will be incremented. So what is count?
Number of nouns.
At least one verb adjacent to it.
Yes,
Correct. So either before it or after it or both sides, we don't care. At least one verb should be there, right?
Yes,
So number of nouns which have at least one verb adjacent to it. Wait. Why is it saying number of verbs having at least one noun adjacent to it? We are checking for nouns in n list.
Ma'am, first we are checking for noun, then for verb.
But count is being incremented for this verb list. So we are checking that. Both way it is true actually.
Both the option A and B.
Yeah, A and B are both going to be true. I mean, the verbs that we are checking for, they obviously have a noun adjacent to them. I mean, adjacency, whenever we talk about adjacency, both of the elements are adjacent to each other, right? So both option A and B should be correct in this case. They have given B, but I think A is also
But
correct.
ma'am, for that particular verb, we are checking just one noun, means the noun after that or before that. It's two different verb we are checking.
Yeah, we
So
are
it should
checking
be
for
option
two
A
different.
only, no? Because
Yeah,
at least
exactly. So we
criteria
are
we are
checking
checking.
for 4 and 6. And number this B will be true when we can say for sure that both 4 and 6 have a noun adjacent to them. Even then it doesn't make sense.
Yes,
We
ma'am,
can
because
only
at first we are checking for the noun and then for the verb. So
yeah,
this
because
means
this I that we are actually
A
having I
noun.
as the for
I
each
is the
block
noun.
element.
N
Yes,
list.
and
N list means noun list.
yes. So the for each block element we are checking for is a noun itself. So only based on that we are incrementing count. I think option A is correct here. Maybe this is a wrong answer given.
Ma'am, option B is saying that only at least one noun. And in this pseudo, we are also checking at least one noun.
Yeah, but see one thing here, that can we say anything clearly about the verbs? What can we say about the verbs? So if I take a particular noun which has sequence number 5, okay. Now for that I am checking whether there is a verb at sequence number 4 or at sequence number 6. If either one of these are there, then I can increment count. So from this I can conclude that the noun 5 has at least one verb. But I cannot say that which of these verbs. So
Yes,
if 5 is that, okay, if 5 is the middle element, that is the noun which has at least one verb on either side. Okay. So either it can be true when either 4 is a verb or 6 is a verb. Right. So obviously whichever is the pairing, or even if 4 and 6 are both verbs, in any case they are adjacent to each other. That means the noun will have one verb adjacent to it and the verb will have one noun adjacent to it. So if you think like that, in that case, both the options should be true. But what we can say with certainty is that number of nouns which have at least one verb adjacent to it. That's what we are checking. I think option A is correct here.
yes, ma'am.
So
If it
because
was
we will only go with the certain conclusion that we can draw. So verb is not the certain conclusion here because we don't know which one is the verb. They can also both be verbs, right?
If
It's
it was
better
and, then the C option will be correct, right?
if it was.
And in between.
Yes. If it was and, that means 4 and 6 are both verbs. Then we can say the nouns which are surrounded by verb. In any case, this is the most probable solution. The number of nouns which have at least one verb. That we can say with certainty. Okay. After this is the last question. Then we will do that recursion thing. So the following pseudocode is executed using scores dataset. So what, okay, this is an important question, okay, in term point of view. What will first of di minus last of di represent for a given key I? So D is an empty dictionary. Scores dataset, you all know what it contains, student data, right? For every card, we have the student name, sequence number, the subjects, physics, chemistry marks, maths marks, and total marks, right? So you pick one such card and we check if that person's town city is a part of dictionary D or not, if it is a key for dictionary D or not. So obviously initially D is empty, so we will be creating keys for every town city, right? So if is key is false, initially it will be false for all unique town cities. So if it is false, then I cannot enter this block, so I will come here, right? If is key D town city. If it is not a key, then I cannot enter this. That means this up to this. Where is this block ending?
On the else block later.
And from here and this here. So this is the if closing. So we'll come to this part. So we'll create a key for that town city and we will store the mathematics marks twice. Okay. In the same list, we are storing it twice. Now, once we have created the dictionary with all unique town cities and maths marks, right? So what happens if two students are from the same town city? In that case, what will happen? Let's say the first card that I pick. Okay. The first card that I pick, that person is from, let's say, New Delhi.
So,
Okay.
ma'am, this is denoting the difference between the highest marks and the lowest mark from the same city town.
Yes, but okay, let's still solve it. Something like that only. So let's say New Delhi is the town city from which the first person is from. So I created one city as key, New Delhi. And let's say that person has scored 80 in maths. So I will store 80, 80. Now let's say the second person who comes is also from New Delhi. So in that case, there is already a key present. So I can enter this if. So here we are checking whether first of D town city. What is the first? 80 is less than the current person's mathematics marks or not. Let's say the current person whose card I picked, who is also from New Delhi, has scored 75 in math. So 80 is not less than 75. That means this if I will not enter. Come to the next if. So here we are checking whether the 80 value is greater than the current person maths marks or not. So it is greater. So in that case, you will enter this if block, and what we are updating is for that town city, for New Delhi, now the list will be first D town city. That means whatever was the first of this list, this one, comma, x dot mathematics means 75. So it will be 80, 75. Now let's say a third person comes, okay, who is also from New Delhi, but he has scored 90. So now what is the, it is obviously already a key. So you come to this if. So what is the first of this list? 80 still, right? It is 80, 75 at this point. So the first is still 80. So check that is 80 less than 90. Yes. So come to this line. Now what we are changing? Now D of New Delhi will be x dot marks, that is 90, comma, last of D dot town city. What was the last? 75. So like this, when we go through all the cards, for every town city, the corresponding list that is stored will have the highest marks and the lowest marks from that city in mathematics. Understood?
Yes.
Anyone who has doubt? The main thing is that we have to just take this as an example. Since we are checking town city, you pick 3 cards with different marks from the same town city. Then only this question will be clear. That what we are updating.
Ma'am, the initialization, from the same card, we are initializing first and last, right? Like,
Yes, initially when we are having, like, we don't have that town city as a key and we are creating the key, then you will have the same marks as first and last in that list. Okay, so
okay,
same
ma'am.
marks as
Okay.
stored twice. Next, when I get a card from that town city for a different student, then you do the comparison. And by the comparison, whatever it is, you will change it like that. So basically, the first element in the list should be the highest marks and the last element should be the lowest marks. So that's why when we do first of DI minus last of DI, it should give me difference between highest and lowest marks of maths from a particular city. Understood?
Yes, ma'am.
So which option? Difference between highest and lowest mathematics marks of city I. This is correct. Yeah. Okay, so we've gone through all the questions.
Ma'am, a small query. Ma'am, you said the number of lines which we are changing need not be like from 4
Equal.
to 9 equal, right?
Yes.
In quiz 2, there was a question where like, could you, if you're having quiz 2 PDF, could once open, ma'am?
Quiz to PDF. I don't think I have it. I have so many
Ah,
PDFs.
which question, Manish? Which question?
The last question, I guess.
Oh, pseudocode 1, 2 wala.
Yeah. Like
If you have it, just share it on the chat and I'll open it. Okay.
I don't have it. Does anyone have?
Just
Because
take a
it's the same question, ma'am. We
screenshot.
have to change lines, but the exact
Ma'am.
number of lines is only the right answer.
So there was another piece of code which was also working.
Yes, ma'am. But it was leaving some empty spaces, which I was like arguing with you before. That's why I was having a doubt.
But that should not be the case. I mean, if the code is working and we are asking that if we can replace that piece of code, then the number of lines doesn't matter. If it is the correct piece of code, then you can replace. Did
Ma'am, I am sending you, but the file is too long. That's why.
no, just take a screenshot of that particular question and send on the chat.
आपके पास चला गया है, देख लीजिए.
Like, is it in? You mailed it to me
No, in the
in
chat
chat.
box.
Okay. Right. Mm,
You have received, I think.
right. Yeah. Which question did you say?
Last question, I guess, ma'am. Like according to my set.
Okay, let me check.
Uh,
I'll share the screen. You tell me which one. Okay.
okay, ma'am.
Alright, this is the paper. Wait, is this the paper? No, this is my paper. Yeah, this. Wait, is this the entire thing? Like all the papers?
All the papers.
Okay. Okay, this is city.
Hmm.
But you check now, okay, which question. So,
This question you have done today, na? At first.
yeah.
Go to the end, ma'am.
Wait, I'll check for questions where there are parts of code.
Yes, ma'am. This question.
This one.
This one.
Yes, ma'am.
Attach question with the previous one.
Okay. So this is the pseudocodes given. 2 pseudocodes, right? Executed on words dataset.
Two pseudocode only, ma'am. But pseudocode 2 is related to the question. We need to only
So
study
what
about
is happening?
I have to once again read the question. I don't remember.
Yeah, no, I'll read. Okay. Count is 0, list is empty. Add something. This is from words dataset. So add something L comma X. X is from words dataset. L is empty. If X word ends with a full stop and okay, let's do add something first. So I is 1, I less than equal to letter count, E is ith letter. If not member of list, then you have to append. So if it is not a member, then you can append. Otherwise, you won't. So basically, list L is going to contain unique letters, right? And after that, you return that back to the main function. If X word ends with a full stop and length is greater than equal to 10, then count is incremented. And L is then again set to empty list. Okay. So if we find such a word that ends with a full stop and has more than 10 unique letters in it, correct? In that case, I will increment count. Okay,
Yes,
is the pseudocode too clear to everyone? Should I explain this? See, count is 0, list L is empty, words dataset has a word in every card. So in list L, we are storing what? Add something LX. Add something LX means control shifts to here. I is initialized as 1. Y is the Y dot letter count is the letter count of that word in X card. So we will go through all the letters in this card, where P is equal to the ith letter of the word. Okay. If P is, first we are checking if it is a member. Okay. So if P is already a part of the list L, M is nothing but list L. So if P is already present in list L, okay, then not of that. That means it will be false. So when this will be true? When P is not a member of L. Right. In that case, this will be true and we will append P to L. So L will contain what? Only unique letters, correct?
Yeah, distinct letters.
Distinct letters. After that, when I come back to the main function here, then it is checking if X word ends with a full stop and length of L is greater than equal to 10. That means greater than equal to 10 means what? 10 distinct letters at least should have. Right.
And
But
ma'am,
the question
still
is that
the list is empty, and we can't reinitialize it from the first.
see what is happening. L will be updated. Okay, L will be updated for every word until I reach the last word in a sentence. That means L has distinct letters from all the words in that sentence. Okay. L is a list containing distinct letters from all the words in a particular sentence. And L will only be reinitialized to empty list when we reach the end of the sentence. Okay. So when we find such a sentence where L is having more than 10 distinct letters, that means that entire sentence has more than 10 distinct letters in it. Then we will increment count by 1 and reinitialize L to empty list. This is the code. Okay, now your question is asking what? What changes, modification should we make to pseudocode 2 so that at the end of execution, count represents number of words having at least 4 distinct letters in the data set. Data set. What does this mean? That means I have to change it in such a way that at the end of execution, count will represent, where is count? Okay, so count was till now representing number of sentences which have greater than 10 or at least 10 distinct letters. Now I want it to represent number of words having
Yes,
at
we
least
have to
4
replace
distinct
from
letters.
line to 9 to 6, and
Not
L should be
ending
out
with
of the
full
second
stop,
bracket.
but it should be greater than 4.
6 to 9, this part should be replaced, right? So it should be replaced with what? This is the correct option. If length of L is greater than equal to 4, then count will be incremented. But my question here is that, wait, just let me check something. That means we are not checking for the entire sentence. We are checking for every word, right? Because this condition is now removed. X word ends with a full stop. So now we are checking for every single word.
So,
And
ma'am,
if for that word,
according to you,
yeah, this is
option
correct.
1 should be correct, na?
No, option 2 is correct. This one is correct. We have to change the entire code from line 6 to 9. Because see, till now we were checking for an entire sentence and checking that that entire sentence has greater than 10 distinct letters or not. But if I change this part, let me write the code. So they're saying that this thing. If length of L is greater than equal to 4, then count is incremented. If
Ma'am, this is correct. Second is correct, but in the first place, what was the doubt, Manish? What was your doubt?
Like my doubt was, is even option C is right?
option
Oh,
C.
let's see.
No.
Like I
Why it
feel
is
it is
wrong?
right.
Because no, it is
In
wrong because L you are not
L is not
reinitializing.
being
L is absent.
L is not being initialized again.
Ma'am, here they're asking for whole data set, right? Not for one
Words
sentence.
having at least words having number of words having at least 4 distinct letters in the data set. So that means number of such words in the data set that have 4 distinct letters. For every letter, you have to reinitialize that list cell to an empty list.
If we
So
don't
this
initialize L to
then
empty
all of
again,
the
it will
distinct letters
get
will keep
counted
on
again
piling.
and again and again.
Yeah. Then you cannot get that answer. Only this option is correct. This line is important.
Oh, okay, ma'am. Ma'am, so pseudocode to if you go to the above question, the before question, the first question. No.
Pseudocode 1.
Okay. This one.
Yes, ma'am. Why is option A wrong?
Pseudocode 2 count represents the number of sentences containing at least 10 distinct letters.
Because full stop was mentioned there, and in the second question, full stop is not there in the condition.
Wait.
There was full stop ending with full stop, and in the second
Here
question,
it is asking that in pseudocode 2 only, it is saying that count represents the number of sentences containing at least 10 distinct letters. That's what it is doing. No? In this pseudocode 2, count is normally in this normal code, count is counting such sentences. No?
and can you scroll down for a second?
Wait, what is the
Number of
difference
words.
between
We are counting.
Pseudocode 1 and 2. Okay, let me check pseudocode 1 also once.
And we are counting only words, and the option is saying we are counting sentences.
No, but you check normally pseudocode 2 if you check.
Right.
Here
X dot word ends with the full stop.
Yes. So till then L will be, it will keep on doing this, right? Adding distinct letters to L until we reach such a word where this if condition is true. The pseudocode 2 is also counting those sentences only, where the number of distinct letters is greater than 10. And what is 1 doing? What is the difference? Let's check the difference between the two codes.
Ma'am, the difference is the L is equal, initialization of L is outside the count, ma'am. Like outside the iteration of count.
Right. So this is outside of the count. That means after every word, it is having L reinitialized. But in pseudocode 2, L is being reinitialized after every sentence. Right? See, here L is set to empty. But when will this condition be true? This if condition will be true only when we reach the end of a sentence. Correct? So L is reinitialized at the beginning of every sentence. Whereas here L is being reinitialized after every word. I think. No, this is the same code. See, this is also falling inside this block of code. Both of these are reinitializing L for sentence only.
No, there was another if block.
The list
but
should be emptied
pseudocode
after
2
closing
has
that
it.
count.
And
Listen, here, whether count is greater than equal to 10 or not, L will be reinitialized. Okay, because L is within this outer if. But here, both of them have to be true. Only then L will be reinitialized. This is the difference. See, here it will check, okay, that X word ends with a full stop. That means we have reached the end of a sentence. Then it is checking whether the length of L till now is greater than equal to 10 or not. Okay. If it is greater than equal to 10, then you increment count. And anyhow, even if it is not greater than equal to 10, then also you have to reinitialize this. Right. So before we go into the next sentence, L is reinitialized to empty list. Whereas in this case, what happens that X word ends with a full stop and length is greater than equal to 10. Only then L is reinitialized. So what happens if I have a sentence where the number of distinct letters is not 10, it is less than 10? In that case, what happens?
Ma'am, it is greater
You are
than equal
saying that the
to
last
10.
word of a sentence is doesn't comprise of 10 letters.
I'm saying that no, that's where you're making the mistake. L is getting updated till I reach the end of a sentence.
Okay.
So L will have all the distinct letters in that sentence till the last word. Okay. Now in this pseudocode 2, we are checking that X word ends with a full stop. That means we have reached the end of a sentence, and the length of L at this point, that is number of distinct words in that sentence till now, is greater than equal to 10. If both these are true, only then count is incremented and L is reinitialized. That means if I have such a sentence where number of distinct letters is 9, let's say, in that case, L will not be reinitialized.
Yes, ma'am. Got it, ma'am. Okay.
Okay, that's the difference.
Yes, ma'am.
Okay, so should we do the recursion thing? No. Okay. Can you tell me which slide it was in? Like which week was recursion? 7.
11, ma'am.
Don't. Recursion
Week
was in. Right,
it
right.
was
DFS one,
5
right?
to 8, na, right? Week 5 to 8.
Yes, it's fine. I will do one problem from recursion.
Just one problem.
If you have time only, okay, because it is already past 8. If you have any other session, then I won't discuss.
Don't we have a statistics class from 8 to 10?
Just factorial, you just
Okay, I have no issue. Okay, I will discuss. Wait. This one, right?
just want to know
11.5.
the flow, how the data, the execution is happening.
Yes. I will do that. Right. Yeah, using this only we can do that. Okay, let me download this. One second. Okay, can you see? Slides? Visible?
Yeah.
Okay. See, this is the procedure, right? Factorial n. So this is the recursive call. How this works is, let's take n as 5. Or let's take it as 4. Okay. So it's not too lengthy. 1 second.
If we have a return statement, the program will give return to the call whenever a return statement comes, right?
It will be returned to the previous call.
In this, normally when we
Normally it is returned to the actual function, yes. Main program.
Here it is different.
Yeah, how it is different, let me show you. So n is 4, right? So first we are checking this is the base case, right? When n is 0, we will return 1. Correct? So initially, let's say this is the procedure we are running with n4. So is 4 equal to 0? No. So come to the else part. So in else part also there is a return statement. Okay.
Yes.
Within which we are calling this factorial. So what will be returned? 4 plus factorial of 3. As soon as I go to this factorial of 3, I have to execute this function again. Right? because as soon as we reach a function call, we have to execute that. So now we will go to factorial 3. And again do the same thing. Check, is n equal to 0? That is 3 equal to 0? No. Again come to the else part. In else part, now the return statement will be what? 3 cross factorial of 2.
So we are not taking the value of factorial 2 here, right? 3 into.
We are calling the function with factorial 2 as the parameter.
So
now there is one more function call.
Yeah, where this
Yeah, how it will be returned, I will show you. See. So this factorial 2 function will now be called. Again, 2 is not equal to 0. So one more return statement.
Yes.
This return statement will be what? 2 cross factorial of 1. Right? 1 is also not equal to 0. So one more return statement. That will be return 1 cross factorial of 0. Right?
Here we
Now,
are
once you
calling the procedure from the beginning or in the else part only?
In the else part. In
Else.
every procedure call, we are going to the else part because it is not equal to 0 yet until I call factorial 0.
Okay, it is not executing the procedure again, only in the else part, return statement, this factor.
It is executing the procedure. See how that I'll write it more clearly. See, this is the first function execution. Okay. This is the first recursive call where we are calling factorial 3. As soon as I call factorial 3, I have to go to its execution. So again, this same procedure is executing except now n is 3. So you first check whether 3 is equal to 0. No. So I am coming to the else part. So I have to again issue the return statement. This is the second return statement now. This is the first one.
Okay.
This return statement contains what? 3 cross factorial 2. Again, I have to execute this factorial. So now you check whether 2 is equal to 0. No. Again, come to the return statement. So now third return call. It is 2 cross factorial 1. Again, you have to execute this factorial. Check if 1 is equal to 0. No. So again, come to return statement, fourth return statement. So now 1 cross factorial of 0. Now check whether 0 is equal to 0. Yes. So I will return 1. Where is this 1 being returned to? To the last call, that is this fourth call. So now it becomes 1 cross 0.
How it is happening? That's what, how that execution happens. Return 1 means we are getting the output of the procedure, right? So how
output of this function call, this particular call, not the entire program.
Yeah.
Every time we are calling this factorial procedure only. But this return 1 is the return statement from the factorial procedure where the argument is 0.
Okay, okay.
And it is returning back to the last call. So it will be 1 cross 0. Now this return statement will also, it will return what? I'm sorry, return 1, right? 1 cross 1. So this 1 value, this will be returned to this last call. So 2 cross 1, this 2 value will be returned to this call. Understood? Now this will become 3 cross 2. This 6 value will be returned to the original call here. 4 cross 6 is 24. So this is the final return value. Ultimately, it will go back to the first procedure call.
So we have to consider that all these statements are somewhere so that we can backtrack after reaching 0, right?
Yes, see, because you are never completing the return statement. As soon as you enter the return statement, you are entering a different procedure. Because the procedure call is within the return statement itself.
Okay,
so after the procedure call is completed, you will complete the execution of the return statement, right?
Okay.
Like that, you will backtrack.
All return statement inside the procedure has to be completed. Then that return value we will be getting our.
Yeah. Yeah.
Okay, fine. Thank you. Thank you for your time.
Yeah, no problem. Okay, so 5 to 8 is done. So next will be 9 to 12. All right. Thanks for joining.
Thank you.
Thank you.